Hello and welcome to the VHDL Packages and Libraries lecture. In this lecture, I'm going to tell you about certain packages or the most commonly used ones in the IEEE library. And the IEEE stands for the Institute of Electrical and Electronics Engineers, and they're the ones that manage the packages we'll be using in our project. In the VHDL language or in the IEEE library, there are quite a few different packages, but we're going to cover the most common ones and specifically the ones that you'll need required to complete all the projects in this course. And these libraries or these packages include the IEEE Standard Logic 1164, the IEEE Math Real, and the IEEE Numeric Standard packages. So for the first one, the IEEE 1164, this one, just some key features. So I'm going to go and review some of the key features for each library, and then we'll go and I'll show you where to go to actually see all of the definitions and the actual code behind the library. So for the IEEE, the Standard Logic 1164, logical operations that are supported in the Standard Logic 1164 library are all of like your AND, OR, NAND, NOR. All of your basic logic gate operations are supported by using the Standard Logic 1164. So by using this package, it allows us to do all of these basic Boolean algebra and different logic operations. The data types it supports are standard logic and standard logic vector. These are the most common, most basic data type used in VHDL, which we'll cover later in the data types section. And the third most important feature of the Standard Logic 1164 library are the functions it supports. And the functions it supports that we use are the rising edge and falling edge. And the way these functions work are when you have a process, you'll use the rising edge function to trigger that process on the rising edge of a signal. And conversely, with the falling edge function, when you have a process and you call the falling edge, you'll trigger that process on the falling edge of that signal. And the next library we're going to talk about a little bit, we have the IEEE Math Real. And some key library features are that it basically supports some mathematical constants and operations. We won't use a whole lot of the Math Real library, but the biggest functions that we're going to use out of here are the ceiling function and the floor function. So with the ceiling function, you give it a number, and it takes you to the nearest integer to represent that number. And the floor is the opposite, where you give it a number and it'll give you the lowest integer used to represent that number. Now in the Math Real library, you have the two different data types it supports are integers and reals, which a real is a floating point number. However, if you're using this math.real library, you can't use real data types when you want to synthesize your design on your FPGA. So when we're using this, if you want to simulate, you can use it to simulate. Like example, if you want to simulate and have a value of pi, it'll represent the value of pi given a constant, but you can't actually synthesize that on your design. So all the designs we use, the only functions are the ceiling or the floor functions, or the two functions we'll actually use out of this library. The next library or the package we have is the numeric standard. And this one, some key features are it supports logical operations such as greater than, less than, greater than, or equal to. And the data types are unsigned and signed. And this is key in that an unsigned data type is very similar to a standard logic vector, except it gives you the ability to do different operations such as an addition, subtraction, multiplication, and division. And you can still access the data at a bit level. Now with the signed data type, this allows you to represent negative numbers. So if you're doing something such as a counter, you can start at 0 and go down and negative, or you can count up. And that's the key features with the numeric standard library. Now let's go ahead and I'm going to show you where to go on your computer to find more libraries, but also how to look in detail and understand what each one of these libraries gives you at a more detailed level. So first, we'll take a look at the Standard Logic 1164. And you can find this on the website of standards.ieee.org. And if you go there /downloads, you can follow the path /downloads /1076/1076.2-1996. And in there, you'll find a bunch of different libraries or different packages in the IEEE library that you can use for your VHDL designs. However, like I said, these three are the common ones we'll be using, but if you go to the website, you'll find this information right here. So when we say we're going to use the package Standard Logic 1164, it tells us the different data types that we have. So here they give you a standard U logic, which is the same as a standard logic, except for a standard logic is a resolved data type. So if you have multiple drivers on your standard logic, it'll resolve it to a single value. And what this means, for example, in the standard U logic, we have multiple values that it can take. It can be a U, which is uninitialized. You can have an X, forcing an unknown, or a 0, which is logic 0, 1, which is a logic 1. And they have the value Z, which is a high impedance. And then our W is a weak, and our L is a weak, and our high is a weak 1. And these are just more or less like a tri-state. So you have a weak 1 or a weak 0, and the dash is don't care. So if you have a standard U logic, if you have multiple signals driving an output, for example, if you have one signal driving at 0 and the other one's driving it a weak high, a standard U logic, if you're using that in Vivado or any sort of design tool, it's going to give you an error saying you have multiple drivers to that signal. Now, if we use a standard logic, it will resolve that to a specific value. So for example, if you have you're forcing it to a 1 and you have a weak 0, the 1 will most likely win and it'll force it to that value. So if we go on down, it kind of gives you some more details here. It goes through the functions, and you can follow this all the way through. I'm just going to skim through and point out the important parts of this file when you're looking at a package and you're trying to review it to determine if you'll need it for your design. So they give you just these subtypes, and this tells you what the value will resolve to. So in here, obviously you can see we have the data type standard logic, as well as a standard logic vector, which is an array of standard logics. And then here we have the logical operations it supports. We have our AND, NAND, and all the way down to our exclusive NOR and our NOT or our inverter. As well as they give us some conversion functions. So if we want to convert to a bit vector, or to a standard U logic, they give you the function that you need to call in order to do these types of conversions. And also they give you the functions at the very bottom. We have our edge detection functions. So we got our rising edge as well as our falling edge, and these are commonly used functions we use in our designs. And the next package we'll look at is our IEEE, our numeric, or excuse me, our math.real. So it gives us some constant definitions, and these are like, for example, it gives us the math constant of E, or math constant of pi. Now to note, these, when it's a real value, we cannot use it to synthesize because real is not a synthesizable data type for FPGA. So these are most commonly used when you're wanting to simulate a circuit. You can use VHDL to do that, and that's where a lot of these constants will come into play. The most common thing we're going to use this library for is specific functions like the ceiling and the floor function. So the ceiling, it returns the smallest integer value as a real, not less than x. So the big thing we're going to do here is we're going to give this a value, and it's going to return the smallest integer value to represent that. And that's key because in integer we can synthesize that inside of our FPGA, so we can use the function ceiling, the function floor. Now if you look at the function round, it'll round to the nearest integer. So as long as it returns it as an integer, we can use it, but if it's as a real, we cannot. The next library we're going to look at, or the package, is the numeric standard. And the big thing about the numeric standard is they have the data types they define, which are the unsigned and signed data type. And then also we have different operations, like they support absolute, subtraction, addition, subtraction again, multiplication, division, as well as all these different, you can do remainders and shifting, modulus. So this gives you the ability to check if one signal is greater than the next. And this is important depending upon your design and what you're doing. If you just have standard logics, like if you're just using the standard logic 1164 library, you can't do a greater than or an addition operation. So if you want to do an addition or a greater than type of operation, you need to use the numeric standard package so that you can define an unsigned data type and add it together or multiply it or any type of arithmetic operation you'd like to do. So now let's take a look in on our project. For example, here in Vivado, you'll notice that we have the keyword library IEEE. So this is the library we're using, and for the button LED project, we're only using the package IEEE.standardlogic1164.all. So this will give us access to create standard logic data types and standard logic vector data types.